The Aurora Australis, also known as the Southern Lights, is one of the most breathtaking natural phenomena on Earth. It is the southern counterpart to the Aurora Borealis, or Northern Lights, and shares many similarities in its formation and appearance. However, the Aurora Australis is unique in its own right, with its own history, scientific explanations, and cultural significance. Today, we will explore the science behind this mesmerizing light show, its historical observations, and the myths and legends that have surrounded it for centuries. To begin, let's delve into the science of the Aurora Australis. The phenomenon occurs when charged particles from the Sun collide with the Earth's atmosphere. These particles, primarily electrons and protons, are ejected from the Sun during solar flares or coronal mass ejections. This stream of charged particles is often referred to as the solar wind. When the solar wind reaches Earth, it interacts with our planet's magnetic field, which funnels the particles toward the polar regions. As these particles enter the Earth's atmosphere, they collide with gas molecules, primarily oxygen and nitrogen. These collisions excite the atoms, causing them to emit light. The color of the aurora depends on the type of gas and the altitude at which the collisions occur. For example, oxygen emits green or red light, while nitrogen produces blue or purple hues. The Aurora Australis is most commonly observed in the high-latitude regions of the Southern Hemisphere, particularly in Antarctica, southern Australia, New Zealand, and parts of South America. The best time to witness this phenomenon is during the winter months, from March to September, when the nights are longest and the skies are darkest. However, the aurora can occasionally be seen at lower latitudes during periods of intense solar activity. For instance, in 1859, during the Carrington event, a massive solar storm, the Aurora Australis was visible as far north as Queensland, Australia, and even in parts of the Caribbean. The first recorded observations of the Aurora Australis date back to the early 17th century. European explorers and sailors, venturing into the Southern Ocean, were among the first to document the phenomenon. One of the earliest accounts comes from the crew of the Dutch ship Eendracht, which sailed through the Southern Ocean in 1619. The sailors described seeing strange lights in the sky, which they initially mistook for fires on the horizon. Similarly, Captain James Cook and his crew observed the Aurora Australis during their voyages in the late 18th century. Cook's detailed logs provide some of the most comprehensive early descriptions of the phenomenon. The scientific study of the Aurora Australis began in earnest during the 19th and early 20th centuries. In 1902, Norwegian scientist Christian Birkeland proposed a theory to explain the aurora, suggesting that it was caused by the interaction of solar particles with the Earth's magnetic field. Birkeland's work laid the foundation for modern auroral research. Later, in the 1950s and 1960s, advances in space exploration allowed scientists to study the aurora from above. Satellites, such as NASA's Explorer 1 and the International Geophysical Year missions provided valuable data on the solar wind and its effects on the Earth's magnetosphere. The Aurora Australis has also played a significant role in the cultural and spiritual traditions of indigenous peoples in the Southern Hemisphere. For the Maori of New Zealand, the aurora is known as Tahu Nui Rangi, or the Great Burning of the Sky. According to Maori legend, the lights are the reflections of torches and fires lit by their ancestors, who traveled to the south in canoes. The aurora was seen as a connection between the living and the dead, a reminder of the enduring presence of ancestors. Similarly, the Aboriginal peoples of Australia have their own interpretations of the phenomenon. Some tribes believed that the lights were the spirits of the dead dancing in the sky, while others saw them as omens of change or conflict. In addition to its cultural significance, the Aurora Australis has inspired countless artists, writers, and explorers. The 19th century British explorer Sir Ernest Shackleton, during his famous Endurance expedition, described the Aurora as a living thing, a presence, a force. Shackleton's accounts of the Aurora, along with those of other Antarctic explorers, helped to popularize the phenomenon in the Western world. Similarly, the Aurora Australis has been a recurring theme in literature and art. From the poetry of Robert Frost to the paintings of Australian artist Fred Williams, the Aurora has captivated the human imagination for centuries. Despite its beauty, the Aurora Australis is not without its dangers. The same solar activity that produces the Aurora can also disrupt satellite communications, power grids, and navigation systems. For example, the 1989 geomagnetic storm caused by a solar flare knocked out power across Quebec, Canada, leaving millions without electricity for hours. In Antarctica, where scientific research relies heavily on satellite technology, the effects of solar storms can be particularly disruptive. Scientists studying the Aurora must therefore balance their fascination with the phenomenon with an awareness of its potential risks. In recent years, advances in technology have allowed us to study the Aurora Australis in unprecedented detail. Ground-based observatories, such as those operated by the Australian Antarctic Division, use cameras and spectrometers to capture high-resolution images and spectra of the Aurora. Meanwhile, satellites like NASA's Themis mission and the European Space Agency's Swarm mission provide global coverage of the Earth's magnetosphere, helping scientists to better understand the complex interactions between the solar wind and the Earth's magnetic field. These studies have revealed new insights into the structure and dynamics of the Aurora, as well as its role in the Earth's space environment. One of the most exciting developments in auroral research is the use of citizen science. Platforms like Aurorasaurus allow amateur astronomers and aurora enthusiasts to report their observations in real time, creating a global network of aurora watchers. This data is invaluable for scientists, as it provides a more comprehensive picture of auroral activity than traditional observatories alone. Citizen science has also helped to raise public awareness of the Aurora Australis, inspiring a new generation of aurora enthusiasts. As we look to the future, the study of the Aurora Australis will continue to evolve. With the advent of new technologies, such as artificial intelligence and machine learning, scientists are able to analyze vast amounts of data more quickly and accurately than ever before. These tools will help us to better predict auroral activity and its effects on our planet. At the same time, the Aurora Australis will remain a source of wonder and inspiration, reminding us of the beauty and complexity of the natural world. In conclusion, the Aurora Australis is a phenomenon that bridges the gap between science and culture, history and legend. From its origins in the solar wind to its role in indigenous traditions, the Aurora has captivated humanity for centuries. As we continue to study and appreciate this natural wonder, we are reminded of the interconnectedness of our planet and the universe beyond. Whether viewed from the icy plains of Antarctica or the shores of New Zealand, the Aurora Australis is a testament to the enduring power of nature to inspire and amaze. Thank you.